Okay, today guys we're going to talk about factoring using the greatest common factor, or GCF. Now before we do that, let's just kind of warm up our brains a little bit and just go back to kind of the basics. If I was going to distribute or multiply this, so let's go ahead and do that. So we're going to distribute the 2 to both of them. So we have 14x minus 6. Okay, making sure that I distribute it to both of them. Okay, now the next one, let's go ahead and distribute this. Okay, we've got to distribute to all 3 of them. So that leaves me with 6x to the, remember we're going to add our exponents, so to the 5th minus 15x to the 3rd, since I have 2 and then 1x, then plus 3 times 7 is 21x squared. The reason why I did this is because when we factor out a greatest common factor, we're going to kind of be working in reverse. Okay, so instead of distributing and ending with this answer, what we're going to do is we're going to start with this answer, and then we're going to write it as this is our solution. And we'll go ahead and take a look at an example here in a little bit. All right, guys, before we get to some examples, though, let's look at the definitions. Factoring. Factoring is the process of writing an expression as a product of its prime factors. In other words, we're writing it as 2 things that are multiplying by each other. So we rewrite it as 2 things that are multiplying by each other. Okay, greatest common factor, or GCF, that is the largest number that can factor into both terms. So it's really the biggest number that can go into our terms. All right, so we're going to just look at listing out factors for things, and we're going to see what the greatest common factor is. So I'm going to go ahead and write out the factors of 12. So the factors of 12 are 1 and 12. I can do 2 times 6, that gives me 12. 3 and 4 are factors of 12. And then that's it. There's no other ones, because 4 and 3, I'm starting to repeat. So now let's go ahead and do the factors of 18. I have 1 and 18. I have 2 and 9. I have 3 and 6. Okay. If I try to divide 18 by 4, that doesn't give me a whole number. So 4 doesn't work, 5 doesn't work, and I'm back to 6. So those are our factors. So I want the greatest common factor, so the biggest number that they have in common. So if I look, the biggest number that they have in common is 6. So my GCF would be 6. Okay. Now let's look at GCF of 9. Okay, so we have 9. Well, I can do 1 times 9, 3 times 3. Okay. Now let's do 14. 14 is 1 and 14, 2 and 7. Okay, so my GCF, the GCF for this one, if you notice, there is no number they have in common, so my GCF is 1, so they really don't have a greatest common factor. Okay, this idea or concept is going to help us when we go to actually factor. Now, one little bit before we do that, when I have variables, you can only factor out the lowest power that they have in common. And that will make more sense when we actually look at an example. All right, guys, so let's look at these when we're factoring. So first thing that we're going to do is we're going to look at our numbers, and we're going to try to figure out what our GCF is. Okay, so I'm going to go ahead and write my numbers down first. So I have 18 and 4. And let's go ahead and list out our greatest common factors. As we get better at this, we don't always have to do this step, but to get going, it's kind of helpful. Okay, so 1 and 18, 2 and 9, then 3 times 6. And there's nothing else that makes 18, so those are my factors. Now for 4, we have 1 and 4. We have 2 times 2. Okay, so now I'm going to look for my GCF, okay, which I notice is 2 is the biggest number they have in common. So my GCF number is going to be 2. Now let's go ahead and look at our variables. So if I look, I have 4x's and 2x's. So we always take the lowest number they have in common. So for this case, is going to be x squared, because they both have 2 in common. Right? So that GCF, we're going to factor it out. Okay, so we're going to factor that out of both of these terms. So I'm going to go ahead and write 2x squared right below it. Okay, and I'm going to factor that 2x squared on the outside. So I'm going to write that down first. Okay, don't forget to put it out front. Okay, now we're going to go ahead and write what we have left. Okay, so 18 divided by 2 is 9. I have 4 x's, and I'm going to take away 2, so now I'm left with x squared. Okay, bring the sign down, so plus. Now 4 divided by 2 is 2. Okay, and then I had 2 x's, and I'm taking away 2 x's, so I don't have any more x's. Okay, so notice how I rewrote my GCF out front, and then I'm going to write what I have left behind in parentheses. Okay, and this is going to be my final answer. I know that I'm done when I look at the stuff inside of the parentheses and notice that there's nothing else I can take out of both of those. Okay, 9 and 2, there's nothing that goes into both of those. One has x's, the other doesn't, so I am done. That is my answer. Now let's look at this one. Okay, so our GCF. Okay, let's try to find that. So I know 7, what goes into 7? 1 and 7, that's about it. Let's see what goes into 21. 1 and 21. And then we also have 3 and 7. Okay, so now greatest common factor, biggest number they have in common is 7. So I know 7 can go into both of them. And then they only have one has an x, one doesn't. So I can't take an x out. So my GCF is just going to be 7. So that means I'm going to divide both of those by 7. Okay, so don't forget to put your 7 out front though. Okay, because we divided it out, so now it's going to be out front. Okay, so now we're going to have 3x minus, I goofed up, not 3x, because 7 divided by 7 is just 1x, or x. You can put a 1 there or put just x. And then 21 divided by 3 is, or divided by 7 is just 3. So our answer can be that, or we can write that as 7 and then x minus 3. Okay, and you can always double check your answer. Okay, because if I went back and tried this again, and just went backwards and distributed it at 7, I should be left with 7x minus 21, which is our answer. Okay, so that's an easy way to check to see if you did it right. But when we factor it, that is going to be our answer. Okay, now I added another term. That's okay. We're going to do the same exact process. We still have to figure out what the GCF is. So I have 16, 8, and 12. So I know 16 is 1 and 16, 2 and 8, 4 and 4. Okay. 8, I can multiply 1 times 8, 2 times 4. Okay, and that's it. 12, we have 1 and 12, 2 and 6, and 3 and 4. So if I look through these, okay, my greatest common factor is a 4. So if I have my GCF up top, okay, I'm going to take a 4 out. Okay, now if I look at the x's, okay, 1 is x to the 5th, 1 is x to the 3rd, 1 is x squared. So the lowest amount of x's they have in common is 2, so I can take out 2 out of all of them. Okay, so I'm going to go ahead and write 4x squared on all of these. Now I'm not doing anything with it, just moving that 4x squared out front. Okay, since that's what I'm dividing by, and let's go ahead and write what we have left behind. Okay, so 16 divided by 4 is 4. I have 5 x's and I'm taking away 2, so I have x to the 3rd. Okay, bring the sign down, so plus. Okay, now 8 divided by 4 is going to be 2, and then I'm taking away 2 x's from 3, so I just left with 1x. And last but not least, I'm going to bring that sign down, minus, and then 12 divided by 4 is 3. And I'm taking away those x's, so there's my final answer. Okay. Once again, make sure that you write that GCF on the outside. If you don't, it's wrong because we're not actually getting rid of it, we're just moving it to the outside. Okay, last but not least, we're looking at this one. Hey, it has another variable. That's okay, we're going to do the exact same process. Okay, so I could list them out, or if we're kind of starting to get better at this, we can just kind of look at what number goes into 15 and also goes into 8. Well, I know 3 can go into both of those. Okay, so 3 is going to be my GCF. Okay. If I look at my x's, I have 4 x's and 5 x's, so I take the lowest number of x's that they both have in common, which would be 4. Okay. This one I have 2 and 1 y, so I'm going to just put 1 y as my GCF. So I'm going to go ahead and do 3x to the 4th y, and then 3x to the fourth y. Make sure we put that out front. Okay. Now inside of the parentheses, 15 divided by 3 is 5. And then my x's cancel, so I don't have any more x's, but I do have one y left. Plus, now 18 divided by 3 is 6. Okay. Then I have one x left, and my y's canceled. Okay. I know that I'm completely done is if I look at this and notice that I have nothing left in common inside of the parentheses. I can't take anything from a 5 and 6, and one has a y, and the other one doesn't, and the other one has an x, and the other one doesn't. So there's nothing left to take out, so that I know that this is my actually final answer. All right, how is factoring related to multiplication? That's kind of the exit ticket, and that's kind of a big concept. Factoring is related to multiplication, okay, because factoring is just rewriting the expression as a product, which is multiplication. So in a sense, okay, when we factor, we just are rewriting it as two things times itself. Okay? So that's how it's related to multiplication, is it's kind of like working backwards. So instead of multiplying something through, we're actually taking that number out. All right, go ahead and get started on your practice problems. Ask questions if you have them. Good luck.